again, like I said, make sure that you study examples 1 and 2 to be able to help you with identifying linear functions from a graph. We already know what the definition of a function is, and what being able to identify it from a table of values. In other words, a table of ordered pairs. I'm going to do it with you as if they give you an equation, how will we determine if an equation represents a linear equation or not? Is it representing, if we graphed it, would we get a line on our graph? Okay? So here's how we decide. An equation is linear if it passes all of these tests. It has to pass all of them. Okay? So if x and y both have exponents of 1. What is going on here today? Okay, x and y both have exponents of 1. In other words, x is to the first power, y is to the first power in the equation. When we have a variable written without an exponent, it's an understood 1. It's been cleaned up. They don't show that 1. So if we have 3x, it's really 3x to the first power. If we have just x, it's really x to the first power. So that's the first test we want it to pass. And then we run it through this test. X and y cannot be getting multiplied together. So nowhere in the equation can there be an x times a y or a y times an x. Then it would not be linear. X and y do not appear in denominators. The downstairs of a fraction. Or basically, in other words, we're saying you can't divide by an x or by a y. They cannot appear in exponents. So something cannot be taken to the x power or to the y power. And the other thing is they can't have any radical signs in the equation. If they are under any radical signs, what I mean by that is that square root symbol. That's a radical sign. We would typically call it square root, but we can also find other roots with it. So our radical sign, if the x or the y appear underneath a radical sign, we do not have a linear equation. So it has to pass all of those tests. Then we talk about if it is linear. One of the forms, we're going to learn lots of forms in this chapter. One of the forms is it can be in standard form. So standard form looks like this. Capital A, little x, plus capital B, little y, equals capital C. So even though you have these completed Casey doing with us, did you keep one of those copies? One of the blank ones that I just sent back?
Do you have handle that?
She was sitting there and I didn't. And one of the things that's really important is you got to have either an x or a y, or you can have both of them, but you got to have at least one of them. So A and B cannot both be 0. If A and B are both 0, that means you don't have any x's or y's. You must have at least one or the other. Okay, so sometimes it is useful to have an equation in standard form, and we're going to learn those ways. So that's why we're going to learn today how to put it in standard form and identify the A, the B, and the C value. Okay? So let's just practice being able to tell if an equation given to us is a linear equation or not. Number 1, 5x minus 2y equals -3. Let's run it through the test. Our x and y both to the first power. There's no power on it. When there's not a power, it's understood to be 1. Okay? Are x and y being multiplied times each other? No, and they can't be, right? So they're not being multiplied. Are x and y in an exponent? Is something being taken to an x power or to a y power? No. Are either of them in a denominator? No, they're not downstairs in the denominator. How about under a radical sign? Is there a radical sign in this anywhere? No. So this one is linear. We would say this equation is linear. So you don't have to write down that you're running through all those tests. If it passes every test, then you say it's linear, and then if it is linear, you put it in standard form, and you identify the A, the B, and the C. Standard form was what we just wrote up there. AX plus BY equals C. The X's and Y's are on the same side together. The constant is over there by itself. Is this in standard form already? It really is, isn't it? Yeah. This is already in standard form, except here's what we're going to do. We're going to change it to add the opposite, so it is AX plus BY. So instead of minus 2y, we're going to change it to plus a negative 2y, the opposite. Now we can say this is standard form. It really wasn't standard form before also. But this will help us identify the A, B, and C more accurately. I like to do it right underneath it, because then I can just, what's my A value? 5. What X is being multiplied by? What's the B value? Negative 2. What's the C value? Negative 3. So when it is linear, we're going to write it in standard form. We're going to identify the A, the B, and the C. Those A, B, and C will play a role at some point. We'll learn more about that later. But right now we're going to learn just how to at least put it in standard form and identify those parts. Questions on it? Let's look at number 2. Let's run it through the tests. What's the first test? I think that's the second test, but that's one of the tests, isn't it? Are X and Y being multiplied by each other? Okay. How about, are they both, what's the first one? They're both exponent of what? 1. Do they both have an exponent of 1?
Yes.
Yeah. How about, are they in a denominator, either of them?
Yes. No. No.
No.
2. Oh wait, no.
Are X or Y, it didn't say does it have a denominator, that isn't what it said. It said are X or Y in a denominator? No.
No.
Are X or Y as an exponent? Is anything being taken to the X power or to the Y power?
No.
Is there a radical sign in this anywhere? No. This is linear also then. Is linear. So now that we've determined it is linear, we have to put it in standard form if it's not already. Is it in standard form? The X's and Y's have to be together on the same side, don't they? And a constant over here. So is this in standard form? Well, the first thing we're going to do though is we don't want our A's and our B's to be fractions. Okay? We want integer A and B values. So just like when we were solving equations, we're not really solving here, but we want to eliminate that denominator of 2. What did we do to eliminate a denominator? Multiply every piece by that denominator. So we're going to take the 4y and multiply it by 2 equals, we're going to take the x over 2 and multiply it by 2, and we're going to take the 5 and multiply it by 2. Every piece must be multiplied by 2. Well, the goal was to get these guys to cancel, and they're gonna. But those are the only 2's that are gonna cancel. So 2 times 4y is 8y. What do we have here? Just x. And 10, right? We have not still put it in standard form, but now we're getting it so that we're going to not have any fraction A and B values. Okay? What do we have to do next, do you think, to get this in standard form? I want to make one move only. I want to subtract x, yeah. You could move the y's over the x's, but then you're going to have to move the 10 over to this side. Because remember, the constant has to be by itself. And the x's and y's can be together. So let's get this x moved over. This is really like what we did back in lesson 1.6 when we were rearranging equations, solving them for a different variable. And we never got like a solution. We got, funny looking things like, well, you can't really take x away from 8y, so you write it like that. But now it doesn't really still kind of look like in standard form because the y's come before the x's, don't they? So if we change this to add the opposite, those two can flip places. They can trade places now. Because in addition, order does not matter. So those guys can trade places, and now does it look like standard form? So our A value, what is it? -1. There's an invisible 1 between that negative sign and that x, right? Our B value is 8, and our C value is 10. Questions? Okay. Let's go to the backside then. Oopsie. Okay, number 3. Run the test. I'm going x, y to the first power. Yes? No?
No.
X and y are both to the first power.
Yes.
Just zero in on the x and zero in on the y and don't care about anything else in the problem. Are x and y to the first power each? Yes.
Yes.
Are they being multiplied times each other?
No.
No. Are they in denominators?
No.
Are they in exponents?
No.
Are they under a radical sign?
No.
Oh, then I guess it's linear. Anybody know what this is called when you have a ratio set equal to another ratio? We've already learned this all the way back in chapter 1, of course, so that was a while ago, I realize, in your young minds. Proportion. How do we solve proportions? What's one of the ways to solve proportions? What are these called? Cross products, yeah. Remember how we took the numerator times the denominator across from it? So we have 5 very important parentheses times x minus 2. We have 3 very important parentheses times y plus 1. When there's more than one term that has to be multiplied, that needs to go in parentheses. Go ahead, get this cleaned up. You know how to do it. You know how to do your own distributive property. Okay, is that standard form?
No.
Why? Yeah, y and the x aren't on the same side even yet, are they? Okay, so what should we do? And then we just can there be constants over on the side of the x's and the y's? No, they have to be on the other side by themselves, don't they? Okay, so what, this is going to be a 2 mover, so what are we going to do first? What are you going to do first? Subtract 3 what? Or subtract 3? I disagree. Anybody else want to disagree? Okay. Corey? You want to just disagree? Okay.
Add 10 to the other side.
How about we move, let's get the y's over here with the x's and the constant over there. Yeah, let's add 10. Or we could have moved the y's first. That's okay. Doesn't matter which one we move. But we eventually need the constant over on the other side by itself. And now we'll get the y's over here with our x's. So we will subtract 3y. Kind of what I thought you were going to ask me to do, but you left off the y part. So we have 5x minus 3y. They're not like terms. It's the best we can do. Lesson 1.6, that hateful lesson. Rearrange the equation equals 13. We're going to do a lot of rearranging equations in this chapter. So welcome back to lesson 1.6. Is it in standard form?
Yeah.
It really is, except it's not an addition, is it? Now, they're not going to show it as addition because they want you to be able to know what it looks like cleaned up also. So this is what I call a cleaned up equation. it probably came from. It could be rewritten like this, but they're not going to show it in an answer bank like that. They clean it up and say, no, just have subtraction. But we should be able to identify an A, a B, and a C without doing that. But if you can't, then you should rename it like that. What's our A value? 5. What's our B value? -3. That subtraction ends up coming along with the 3. And what's our C value? 13. Okay. So I'm just telling you, this is probably not how you're going to see it in an answer key. They will clean it up and say standard form is this. And then you got to know that that means plus a -3, so your B value would be a -3, not a +3. Okay, let's look at number 4. 3xy = 6. Why is it not linear?
X and Y are being modeled.
Yeah. So here's what we're going to write. Is not linear. But we don't get to just stop there, because then you just do that for every problem in your homework. You say, it's not linear. Then I don't have to put it in standard form, and then I don't have to find A, B, and C, right? You have to justify why it's not linear, and you just told me. Because X and Y are being multiplied. Takes just one part of the test, it doesn't pass, and it's not linear. It doesn't have to flunk every piece, just one of them. Sometimes it might flunk more than one of them. So you might come up with a different reason than somebody else if it doesn't pass a couple of the tests. Okay, number 5. 4x = -8. Not linear? Which test doesn't it test? Which test does it not pass? Doesn't have a y? Oh, is that one of the tests? If it doesn't have a y, it can't be linear?
It's linear.
It's linear. Yeah. It passes every test. And remember I said to you, it has to have at least an x or a y. It can have both. It has to have just one of them, really, to be linear. This would be linear. So if it is linear, then we have to say, what's its standard form? It's already in it, isn't it? Are there any y's in this? So we're not going to invent any. So the x's by themselves, and is the constant by itself? So this is already in, so let's put that already in standard form. It's okay that there aren't any y. Well, then what's our A value? 4. What's our B value? 0. Y got multiplied by 0 to get rid of them. 0 times something eliminates it. It's gone. So our B value is 0. But remember it said A and B both can't be 0, but it didn't say one of them couldn't be. And C is -8. Okay. Questions? Again, this is the trickiest part of this lesson. That's why I went through this part with you. But I expect you to study example 1 and 2 on your own to help with those types of problems in your homework. So anything unclear yet out of these 5?